Hi students, welcome to physics class. In this video, we will discuss about one-dimensional elastic collisions. Let us consider two bodies of mass m1 and m2. They are moving with initial velocities u1 and u2. After some time, they will collide. After collision, they move with final velocities v1 and v2. We know that it is an elastic collision. It is an elastic collision. In elastic collision, momentum remains constant. Momentum remains constant. That implies momentum means mv, which is equal to constant. Here, m is the mass and v is the velocity. By applying this condition to the above system, then we get momentum before collision is equal to momentum after collision. Now, by writing the momentum for the first body, we will get m1 u1, and for the second body, the momentum is m2 u2. Here, product of mass and velocity gives its momentum. In the same way, here product of mass and its velocity gives its momentum. The two bodies momentum before collision is equal to the two bodies momentum after collision. That is, for these two bodies, the momentum is m1 into v1, that is mass into velocity, plus m2 into v2. Now, by taking m1 terms to left side and m2 terms to the right side, again, we know that in a collision, in elastic collision, kinetic energy remains constant. Kinetic energy remains constant. That implies half m v square is equal to constant. That is, kinetic energy before collision is equal to kinetic energy after collision. For the two bodies, in order to calculate its kinetic energy, we will multiply its mass with its velocity square. For the first one, let us imagine the figure and write down the kinetic energy equation for individual objects. For the first one, half its mass is m1 and its velocity is u1, therefore half m1 u1 square, plus for the second object before collision, half m2 u2 square. In the same way, after collision, half m1 v1 square for the first object, and for the second object, half m2 v2 square. By cancelling the common term half in left and right sides and taking m1 terms to the left side and m2 terms to the right side, now we have two equations. First one is the first expression, and we have another expression denoted this one as equation number 1 and this one as equation number 2. Dividing equation number 2 with equation number 1, we get, by cancelling here m2 and here m1, by applying a square minus b square is equal to a plus b into a minus b formula. For these two expressions, we get minus u2, v2 minus u2 are the same terms, they cancel out. In the same way, u1 minus v1 gets cancelled. Finally, we get u1 plus v1 is equal to v2 plus u2. Finally, we have u1 plus v1 is equal to v2 plus u2. By taking v2, we get, by substituting this v2 expression in the equation, we get, substitute the v2 value here, m1 into u1 minus v1, that is equal to m2 into v2 means u1 plus v1 minus u2 minus u2. This is v2 minus u2. Next, by expanding, move the v1 terms to one side, m2 v1 plus m1 v1, and moving these two terms to left side, then we get m1 u1 minus m2 u1 plus 2 m2 u2. Now by taking here u1 as common, m1 minus m2 into u1 plus 2 m2 u2 is equal to m1 plus m2 into v1. Dividing the whole term with m1 plus m2, then m1 plus m2, then we get, which is equal to m1 minus m2 divided by m1 plus m2 into u1 plus 2 m2 divided by m1 plus m2 into u2. This is the expression for the final velocity of the first body. In the same way, we will write the expression for v1, which is equal to v2 plus u2 minus u1. By substituting this expression in the equation m1, we will substitute this v1 value in this term. Then we get m1 into u1 minus of, by substituting v1 term, v2 plus u2 minus u1 is equal to m2 into v2 minus u2. By multiplying the term, by moving the v2 terms to right side, then we get m1 v2 plus m2 v2, and moving this term to the left side, then we get m1 u1 minus m1 u2 plus m1 u1 plus this term m2 u2. Here we have m1 u1 terms twice, so we can write 2 m1 u1, taking minus as common and u2 also as a common factor. Then we can write these two terms as m1 minus m2, which is equal to, by taking here v2 as common, v2 into m1 plus m2. Dividing the whole term with m1 plus m2 on both sides, then we get v2 is equal to, this is the final velocity of the second body. Final velocities of two colliding bodies.